Eclipse stream. My name's Haley. I'm one of the educators here. And
I'm Claire. I'm also an educator here.
Hi, yeah. So today, me and Claire are going to talk to you guys a little bit about what a lunar eclipse is, as well as touring the moon for the different Apollo landing sites. So if you guys are ready, we have this beautiful view of the moon right now, which is really nice because it was pretty cloudy when we first got up here. Hopefully it'll stay clear for us, but take advantage of it while we can. Now, we like to start with talking a little bit about what a lunar eclipse is. So if I could go ahead and share my screen, I'm going to show you guys a really nice graphic of a lunar eclipse so that we can really see what we're actually going to be looking at. So if I can take over the screen sharing, please. Awesome. So let's go ahead and take a look at this guy. So this is a graphic that I got from NASA, and you can see here that this is what eclipse looks like. So a lunar eclipse happens when the sun, the Earth and the moon are aligned like this, with the Earth between the sun and the moon. So you can see here that there are actually two shadows coming from Earth. We have a penumbra and an umbra. So a penumbra is that outer edge of the Earth's shadow, and the umbra is the inner part of the Earth's shadow. So tonight, we're actually going to see three different types of lunar eclipses. Those three different types of lunar eclipses are a penumbral lunar eclipse, a partial lunar eclipse, and of course, a total lunar eclipse. So a penumbral lunar eclipse happens when the moon passes straight through that penumbral area of the Earth's shadow. And that is going to occur here in Flagstaff at 1:47 a.m. And then we are going to go ahead and move into the partial at 2:44 a.m. So we've already gone through the penumbral part of the lunar eclipse. We're heading into the partial, where it's going to be partially into that umbra. And then the peak of the total lunar eclipse will actually be at 4:18 a.m. It starts at 4:11 and ends at 4:25 a.m. So this is what it's going to look like. And you'll notice that in this graphic, you can actually see kind of a red shadow on the surface of the moon. So that red shadow has to do with how the light is actually coming onto the surface of the moon from the Earth's shadow. And so that's going to happen around 4:18 in the morning today. So we can go ahead and take a look back at the moon again. So how often do lunar eclipses happen? Well, this is a question that we get quite often. So a lunar eclipse happens only at a full moon, as well as only when the moon is on the same plane as the Earth. So what I mean by that is the moon actually rotates around the Earth at a slight angle, right? A slight tilt. And so every once in a while, the moon will be perfectly level with the Earth, kind of like this, instead of like this. And so it's only that at that point in time that we can get a total lunar eclipse. And these are pretty rare events. They only happen maybe once or twice a year. And it looks like I have a question from Matthew Cooper asking if we would be able to see the lunar eclipse in Buffalo, New York. And it actually turns out that the moon has already set there. So this is actually only going to happen on the West Coast that you'll be able to view this. But thankfully you're checking out our total eclipse stream because hopefully we'll be able to see it from here. Yeah, so I just wanted to explain a little bit about how the moon, how the lunar eclipse is going to happen. And now I'm going to hand it over to Claire, and she's going to talk a little bit about the theories of the moon formation. Before we do that, though, we can actually see the shadow on the surface of the moon right now. So like I said, we're heading into that partial lunar eclipse. So you can see we're pointing out that shadow right there. And that'll peak in about 4 minutes, and then we'll start heading towards the total lunar eclipse. So Claire, if you want to talk a little bit about lunar formation, go for it.
Yeah, and so just before I head over there, I just want to mention that if you keep your eye on the live moon section that we have on the stream, you'll notice that the moon will be slowly getting red over time. So again, the actual max eclipse is at 4:18, but when we lead up to that, it'll start to change its color a little bit. So keep an eye out for that, because as we enter the partial eclipse, that's something that will occur over time. So just keep an eye out for that. But if I could pop over to share my screen, and I'll get you guys a cool little thing going up here. So let's see. Let me get this guy up. All right, let me move the chat out of the way real quick. Ooh, there we go. Okay. Whoops, wrong thing. There we go, wrong button. Okay. So I was going to talk a little bit about theories of moon formation. So it's always kind of a big question of how is the moon even here orbiting us right now, or how did it form, where did it come from? And there's a couple interesting theories. So we're going to go ahead and go through some of those. So the first ones I'm going to talk about until I get to the last one are actually theories that we have mostly disproven. So these are theories that have come up over time to try and explain how the moon has come to us. But for the most part, there are reasons why we don't actually use or believe in these theories anymore. We've largely disproven them because there are some inconsistencies, and I'll explain those. But the first one that we have is called the fission theory. And so this was where the moon was once part of Earth and kind of was just like flung off from the Earth. So you can kind of see in this graphic right here, we have Earth in its early state, so that's kind of why it looks like a bit of a fiery ball. And as it rotates quite quickly, a big chunk of rock will kind of just be flung out from it. And so that's one way that we think the moon formed, is that it was actually part of Earth and just separated somehow. And a candidate for where the moon was on the surface of the Earth when we think this happened, or when the theory was proposed, was the Pacific Ocean basin. We think that that might have been where the moon was from, and then again, it kind of just flung off itself from Earth. And why we considered this a theory, so the moon and Earth composition are fairly similar to each other, specifically with Earth's mantle. So not necessarily Earth's crust, but Earth's mantle and the moon have some similarities in their composition. So that was kind of a drawing factor to us. But why it has largely been disproven, at least this first theory, is because the Earth spins the lack of fossil evidence. So in geology, we use quite a lot of fossil evidence to try and formulate the ages of the Earth, basically. So there's lack of fossil evidence for this occurring, which kind of is a hole that we can't really fill in, and fossil evidence is really important for that, and we can't quite find it for this. And there's also no explanation for how the lunar surface looks today. So the lunar surface, also with geology, has quite a lot of what we call baking, which basically means that the rock has been heated up to an extremely hot temperature. And with this fission theory, we can't exactly explain that. So that's another inconsistency that we have. So we know that based off of looking and studying the rocks on the moon now, that it has gone through a period of extreme heating. And with this first theory, we can't really explain that. So that's one of the reasons why it has been largely disproven for this first theory. The next one we call the capture theory, and this one's pretty easy, is that the moon formed from somewhere else in the solar system and was just caught by the Earth's gravity. So you can kind of see in this graphic here, we have the moon and it's kind of flowing towards Earth, and then eventually it will be sucked into Earth's actual orbit. And then that's how we get how the moon orbits the Earth. Now, this one seems kind of cool. It does explain some of the inconsistencies with how the Earth's composition is a little bit different from the moon's composition in the way where they formed from different areas in the solar system. But another way that this doesn't quite match up with what we think this should explain is, again, with how we can know that the rocks on the surface of the moon have been heated quite a lot. This theory also does not really go into that. And so it just doesn't quite fit all the puzzle pieces together. So we figured that maybe there's still something else that we are missing with some of these theories of formation. So for the most part, these two have largely been disproven because they don't quite explain everything that we need them to. But if we go on, there's one more that has been largely disproven. It's called the condensation theory. So basically, Earth was surrounded by a bunch of debris, and over time, that debris kind of accumulated into the moon. Now, this might seem rather similar to what we think the theory of the moon formation is today, but I'll get into some of the differences. And like the last three that we talked about, this one also doesn't explain how we can know that the lunar rocks have been heated over time based off of some sort of event or cataclysm that must have heated those rocks up quite a bit. This one just doesn't quite explain that. And so that's why it's also largely disproven. We also know that this one's largely disproven because if they formed in the same vicinity like this, so the Earth and debris, same vicinity basically, they should have the same exact composition. And again, we don't quite see that. So that's another thing where we know that this one isn't quite right. So there must still be another theory out there that explains this a little bit better, where it can include how the moon rocks have been baked in a sense, and also explains how the composition is going to be a little bit different from Earth itself. And so we call that theory the Great Impact Theory. And so this is the one that we're most confident in today. And it's pretty simple. Basically, a rock pretty much the size of Mars came towards Earth at one point, crashed into us, created a bunch of debris around us, and then that debris eventually coalesces into the moon. So it does kind of involve some aspects of the last theory that I talked about, but it does involve the step of actually having that massive impact, which would help explain how all of those lunar rocks went through that event of intense heat, basically. And we can see that on the surface, basically, of the moon. And so this one kind of puts all the pieces together and helps us explain all the things that we need. So this is the one that we think is the most popular today. And so we call it the Great Impactor Theory, where again, basically a chunk the size of Mars crashes into Earth, and then we get the moon out of that. And so this one, again, it explains the baking, it explains the difference in composition, and it kind of puts all the puzzle pieces together. So this is why we think the moon is here today, based off of a giant impact in Earth's past. And this theory was proposed around the 1970s. So not all that long ago. It took us a while to actually figure out that this might be the one that we wanted, but it does fit pretty well so far. And so this is the one that we have kept for the most part. However, there is still a lot of research going on to theories of moon formation. So this is still a theory, which means that once we get more science and once we start researching a little bit more and continue to do research on the moon, on the Earth, on the solar system, we may change this theory over time when we get more information. So keep in mind that theories can change, even though theories are some of the most concrete ways that we can explain things in the universe. They are always subject to change based off of science. So definitely just keep that in mind. But this is the one that we have the best so far. So it looks like I have a question. Make sure I didn't miss any. So we have a question. I think it's fission theory because every planet has a moon. So different moons can have different formations. So maybe how Saturn's moons formed was a different theory, basically, or a different event that happened than what happened with Earth. So all of these moon formation theories can maybe apply to other moons around other planets, but not necessarily to our own moon with just us. So I guess that's one main difference that I'm catching up on here. But that's mostly all of the moon formation theories that we have. So again, the Great Impactor Theory is the one that we're most confident in right now, but it could be subject to change over time. So I think we're going to pop back to the live view to try and get some of that stuff going on. So I'm going to stop sharing. We should be good to go back to our live view through the Malincam. Let's see. So it looks like we're starting to get the penumbra in the Malincam now. Sweet. So again, we're definitely in that partial phase. We just passed it about 6 minutes ago, so we should hopefully be able to start seeing some of that color change coming up on here. So keep an eye out for that. So you can see on the top that it's quite shadowed. And over time, that moon will be able to turn a little bit more red over time as we enter into the total eclipse phase. Sweet, so I think I'm gonna, let's see, we're checking the schedule real quick. I think I'm gonna hand it back to Haley so she can talk about some formations on the moon, and then we can also take a little bit more detailed live views as well.
Yeah, thanks, Claire. So I did notice that we had a couple of questions about the actual eclipse and viewing of the eclipse. So yes, I at the beginning told you guys that the east coast, the moon has already set. And it's not that you missed the lunar eclipse, it's that you won't be able to see it in general because the moon isn't in the night sky right now. So you will, however, be able to see it here on our live stream. So like Claire was saying, if you look at this image right here, that really, really dark shadow up to the top left, that's where the moon is passing into the umbra. And then we can see the lighter shadow off to the right, or the bottom right there, and that is passing into the penumbra. So earlier when I was talking about different types of lunar eclipses, this right here is a partial lunar eclipse because it's partially in the umbra right now. But as the live stream continues on, it'll eventually cover the whole moon and we will see that fully red color that you associate with lunar eclipses. And I also see a question about where's the best place to watch the lunar eclipse in Flagstaff. So it is going to be a little bit lower on the horizon. So ideally you want to be somewhere where there aren't a ton of trees on the horizon, and you'll be able to get a really, really good view of it. And of course, as with all astronomical observations, the higher up you are, the better the seeing conditions are. So if you get yourself a little bit higher up, that's going to be where you're going to get those really, really good views. So now we can talk a little bit about the formations on the surface of the moon. So I want to start with something called riles. So riles are going to be the long, narrow depressions that look like channels on the surface of the moon. And I like to point these out first because it's very similar to something that is near and dear to Lowell's heart. And that actually has to do with our founder, first director, Percival Lowell, who looked at Mars and he saw what he thought were canals on the surface of Mars. So he thought that there were these giant man-made channels on the surface of Mars. So I have a job because of aliens, which is pretty cool. But you can see here, the moon actually does have these channel-looking structures as well, and those are those riles on the surface there. And then if we continue on, we've also got types of shield volcanoes on the moon called domes. So the moon was at one point in time sorry, I'm reading the chat questions. So the moon was geologically active at one point. And so that means that it had some form of molten core. And that molten core, as the moon got hit by debris or was gravitationally influenced, it caused volcanoes to erupt on the surface of the moon. Very, very similar to those that we see in Flagstaff or on Earth in general. And so these volcanoes, they erupted, and they have a little bit of a dome-like structure on the surface of the moon. And they actually caused all of those dark regions on the surface of the moon. Those are called maria. So maria is Latin for sea. And these are basically seas of dried basaltic lava rock. So basaltic lava rock is extremely common here on Earth. And we thought it was pretty cool that we actually found extremely similar types of lava on the surface of the moon. As we do here on Earth. And that kind of makes us lean towards the formation theory that Claire was talking about, where a piece of the Earth kind of broke off because the moon is very geologically similar to the Earth. Now, there's a couple of different types of features on the surface of the moon, things like wrinkle ridges, which I think is a funny name, but it's basically buckling on the surface of the moon, and that's due to tectonic forces. So tectonic forces, that's actually something that occurs here on Earth and causes earthquakes, right? So that would be tectonic shifts. And so that used to happen on the moon when it was still geologically active. So not only did it cause those wrinkle ridges, but it also caused things called grabens. And grabens are basically giant canyons on the surface of the moon that were created because of these tectonic shifts that we see. And I have a couple of questions that I'm going to address before I continue. So it looks like we have a question from Nicole Rudy. It says, why does it look like it's at the bottom left in Hawaii and the top left in our view in Flagstaff? So that has to do with perspective. So the way our Cam is set up and it's looking at the moon, it's actually going to appear almost like inverted from what you are seeing there in Hawaii. So depending on where you are on the surface of Earth, it's going to look like the shadow is in a little bit of a different area, but you will consistently see the same amount of shadow. So in this case, you see, what does that look like? Maybe a fourth, maybe close to like a third of the moon is covered in that umbra. And then about halfway down, we also see the penumbra. So it's going to be a similar ratio, but maybe not quite so, opposite. So the Cam, it's at about a 90-degree angle in its mount. So we're seeing this 90-degree shift than what you would see there. Now, Leila Bino said, can I see it from California? So you should be able to see it from California. And you should be able to see most of it. So like I was saying earlier, it is probably going to be closer to the horizon as the full total lunar eclipse happens. So just try to look a little bit closer to the horizon to find this. And then if you're watching the eclipse unaided and in the northern hemisphere, you're actually going to be seeing the shadow come from the lower left of the moon. So keep an eye out for that. You'll start seeing it from the lower left, and it'll slowly envelop the entire moon. Now, there's one more thing that I want to talk about with the formations on the moon, and those are highlands. So if you guys could turn the exposure time down a little bit. So you can see those darker areas, those maria that are on the surface of the moon. And then you can also see some really bright spots there, and those are the highlands on the moon. So these brighter areas, those are actually some of the oldest formations on the moon, some of the oldest areas on the moon. And you can tell because those craters are kind of fully intact, right? So we have these maria that are kind of smoothed over, that basaltic lava rock that overflowed from all those volcanoes. And the highlands are basically home to a lot of impact craters, and they're nearby a lot of impact craters. So impact craters, that's just where the moon was hit by different things, and those caused craters to form. Now, these craters, you can actually see kind of like a spray pattern around them. And that's very similar as to if you've ever like thrown a rock at sand and you see it kind of spray out from the sides. That's basically what happened here, except on a very like much larger scale. And we see a little bit of this here on Earth as well, where we find craters. And there's actually two craters very close to Flagstaff, Meteor Crater and Sunset Crater. And when the initial Apollo astronauts were studying to go to the moon, they actually came out here to Flagstaff to do a lot of their training. And that's because they wanted to go out and see these different craters. They also went and blew some holes in the, they also went and blew some holes in the cinder piles north of town. And those cinder piles, they set up all of their like buggy, their different lunar rover experiments, and they kind of rode around to simulate what it would be like to rove around on the moon with these craters. I have another question. How long does the eclipse last? So the duration is about 5 hours total from the penumbral lunar eclipse, partial lunar eclipse, total lunar eclipse, and backwards. But the full eclipse, the total lunar eclipse, where you'll see that kind of red color, is going to be about 15 minutes long. So those are the different types of formations on the surface of the moon. And to go along with this whole Apollo missions, how we actually studied to go to the moon, I'm going to hand it over to Claire, and she's going to talk a little bit more about where those Apollo missions landed on the surface of the moon.
Sweet. So before we do that, I know there's another question that is asking us if this is just a picture or if this is the live moon. So this is a live image. So the telescope and the camera that we're using, we're actually, if you can kind of look on the side, I think we're on something and it'll say it's on video mode. So we're actually just taking a video of the moon right now. So this is completely live for you guys. And on the side, you'll see like a control panel, which basically just dictates how we can change exposure times on the moon. So sometimes high clouds might pass over. Again, we mentioned earlier in the evening that we were dealing with some clouds earlier and we might be dealing with them a little bit later. And so we might be changing the exposure times based off of that. But this is a completely live view for you guys. And we're using something called a Cam camera attached to our Planewave telescopes. So this is completely automated. We just use computers and it's really awesome and cool. Definitely one of my favorite telescopes. But again, this is totally live for you guys, so you're not missing a beat at all. There's actually two live views. I totally forgot about the second one. So right now we're looking at the Cam, and then we have a little Vixen refractor that we're also using. And the reason we're using two is that when the moon gets a little bit lower, our Cam telescopes won't quite be able to look quite as far south. And so we have a second one set up so that we can be able to see the full eclipse in all of its glory and we won't miss anything because of the trees or the horizon or anything like that. So we have two so we can get the best view out of both of those. So I'll go ahead and talk about some of the areas that we have landed on the moon and also the Apollo missions. So let me pull that up. Let me just take a look at the moon right now. And so actually what we're doing right now is we're using a function called like the jog function. And so we're just clicking these little arrows and we're moving the moon around in the actual view right now. So we might do that just to make sure it stays centered and or to look at different aspects on the moon. Sweet. So I think I'm gonna show you guys like a really cool piece of software that you can actually download and use on your own computer. So if I could get the screen share again for just a moment, and then I can show you guys some cool things with that. So I'm gonna go ahead and move up here. All right. Sweet. So let me move this thing again. I think it's loading. It might be a little bit angry that we're on a live stream. If that doesn't work, that is okay. There we go. It's starting to come up. But basically, this is something called JMars, and it says Mars, but that's just based off of the software that we are using currently. And it's free to download on your own computer, and this is one of the coolest like public science software that you can actually get. So you can load up a bunch of really cool layers, scientific layers that you can get from the Lunar Reconnaissance Orbiter and a bunch of other things. Right now, what I have is basically just a basic global map. And so this can allow me to go anywhere on the surface of the moon and look at it in a lot of high detail. And so the reason I chose this is that the Cam is really great, but sometimes we want a little more detailed view of possibly where the Apollo 11 missions landed. And so I'm going to show you a couple of them here and also talk about what they did on the surface. So again, this is called JMars. You can go to the website, download it for free. It's really cool. You can use it for other planetary bodies as well, such as Mars or asteroids and other things like that. So I totally highly recommend if you're interested. But the first one we'll start off with, and I guess I should give a little bit of context to the Apollo 11 missions in the first place, is that it all starts with the space race, basically. And that basically started when the Russians sent up a satellite called Sputnik. And we realized that space was now a frontier that we needed to explore and also possibly take some more dominance in. And so over the series of time, we sent more spacecraft, we sent people orbiting Earth, and then eventually President Kennedy decided that we should go to the moon. And so he set that goal for us. And so NASA got started on all of these. And so the Apollo missions are really what this is about, is sending the first man to the moon. So we're going to go to the Apollo 11 landing site, which is where we landed the first man on the moon. So those famous astronauts like Neil Armstrong, this is where they landed. So I'm just looking at the coordinates right now. That's why I'm looking down. So I'm going to type them in. So it's 0.71 degrees north and then 23.63 degrees east. Oops, I think I have to add a 0 here. And remember, I did that last time. 23.63 degrees east. So I'm going to go ahead and hit enter. And then if I zoom in, probably let's do 128 times, see if that will load up for us. There we go. So basically we can't see the exact tiny little part that they landed in, but basically right in this area right here is where they landed. And they landed in what we call the Sea of Tranquility, or Mare Tranquillitatis, something like that. And the reason why we landed in these areas is they're rather smooth relative to the rest of the moon. So if I zoom out again a little bit, you notice that this part is really cratered, looks really rocky and rough. And if we go in this darker area, then it looks like it's a little more smooth, a little more safer to land. When we zoom in a little bit more, there's just going to be an abundance of craters still. So you can see just these tiny little pockets right in here. So there's still quite a lot on the surface that we can't necessarily see until we get up real close. But for the most part, it is a lot smoother than the rest of the moon. So that's one of the reasons that we decided to land in these areas. And in fact, I know Haley has a really cool aspect of how we actually started choosing spots to land. And I know she likes talking about this, so I'm going to let her speak about mapping the moon real quick with Lowell Observatory.
Yeah, thanks, Claire. So I don't know if many of you guys knew this, but a lot of the lunar mapping for the initial Apollo missions happened here at Lowell Observatory. Now, Lowell Observatory was approached by the Aeronautical Charting and Information Center, and they asked if they could use our Clark refracting telescope, our 24-inch Clark refracting telescope, to map out the moon for the lunar landings. Now, the best way to map out the moon was really to just look at it with your eye and draw what you saw. And there's a couple of different reasons for this. One of the main ones is because your eye only takes in fractions of seconds worth of light, which means if there's any type of atmospheric disturbance, your eye will just kind of overwrite it. Whereas if you're taking like a long exposure photo, that atmospheric disturbance will show up on the photo. So it was actually with both of these methods combined that we mapped out the moon for the lunar landings. So on the astrophotography side of things, the main photographer was actually Bob Malfair. He went on an astrograph, which takes long exposure photos, and he would take these really, really nice photos of the surface of the moon. And then he would hand it off to Patricia Bridges. Patricia Bridges was the main cartographer for the lunar mapping, and she perfected this beautiful type of artwork, airbrushing work, that is still called the Bridges method today. And Claire, if you'll hand over the screen sharing, I can actually show you guys some pictures that she created. So let's see. Oh, wait, that's the wrong one. My bad, hold on. So let me pop up the images right here. So I have, this is one of the early pieces by Patricia Bridges. So you can see here that it's got a little bit less of, oh, where did it go? Oh no. It's got a little bit less definition at first, and it won't go back. There we go. So it's got a little bit less definition right here. You can see these crater-like areas in here. And then she started to perfect her airbrushing technique, and the maps turned out something like this. So you can see lots and lots of detail in here. And it's actually funny, Claire, you can take back over the screen sharing. They actually would have Patricia Bridges in the ACIC building, and she would be doing all of this airbrushing and putting on all the details. And they would be looking through the Clark, waiting for really great viewing conditions. And they had a phone in there, and they would call her whenever these great viewing conditions would be happening. And she would have to like run up from the building and go into the Clark and start drawing what she saw. So it was a really cool process making these maps here at Lowell. And the maps actually turned out to be extremely important, because it turns out that when they were initially landing on the moon, they looked down at the maps and they looked at the autopilot and where it was going to land. And it turns out that they were actually going to overshoot the Sea of Tranquility altogether. And if they did overshoot the Sea of Tranquility, they actually wouldn't have enough fuel to leave the surface of the moon. And there's a really crazy video of you can just hear Houston over the radio counting down the seconds that they have in order to land before they run out of fuel and couldn't get off the moon. So they actually ended up using some of these maps in order to safely get on the moon and safely return. So that's a pretty cool fact that I don't know if a lot of you know, but Lowell Observatory has a pretty important lunar legacy here. And it looks like we have a question. How often does a full lunar eclipse happen on a supermoon specifically? So the answer to that is actually maybe only once or twice a decade. So very, very infrequently. Total lunar eclipses, like I said earlier, they might happen like 1 to 2 times a year, but potentially maybe only once or twice a decade for the supermoon full lunar eclipse. So that's something really cool that you guys are getting to experience today, right? Because this is a pretty rare occurrence. And I want to point out real quick before I hand it back to Claire that we are now 1 hour away from totality. So set your clocks, right? Get ready, because we're about 1 hour from the total full lunar eclipse on the big, huge supermoon. So yeah, that's a little bit about Lowell's lunar legacy. Now, Claire, if you want to take it back and talk a little bit more about the landing sites.
Sweet, that sounds good. So, just with the Apollo 11 mission again, I just wanted to briefly talk about what they actually did on the surface. So, the astronauts Armstrong and Aldrin spent about 21 hours and 36 minutes on the surface of the moon, which is a lot of time without sleep, in my opinion, but I guess I'm doing it right now, so can't be terribly bad. And what they did is they gathered samples of moon rocks, which are pretty cool. They took extensive photography on the actual surface, which is pretty important. They employed or deployed a TV cam to transmit signals to Earth so that we could start up some of that science as well. And then they set up a couple other experiments that might look at solar wind and other things. Just basically, we set up experiments to investigate more what the lunar surface is like and how it is affected by the sun and other things like that. So they set up some of our basic science experiments on the surface. And I believe at first that when the Apollo missions were first starting, our main goal was to just get the first people on the moon. That's what we were really focused on. And then for a little while, we kind of forgot that going to the moon is really important for science. So we actually almost forgot about that at first. We just wanted to send people there and then bring them back. But then we're like, wait, if we're spending all this time and money to actually send them to the moon, why not do science there? And so we kept doing that over time. So I'm gonna just look at the chat real quick. So let's go to the next one. We can go to Apollo 12, which I believe is pretty close by, but we can go ahead and take a look at that. So I think it is at 3.04 degrees south. So change that over, and then 23.42 degrees west. So I'll change this guy as well. So I should hit enter and it should bring us there once the actual map does its thing. So I'm going to zoom out a bit just so we can get a little more context. So we're in about the same area, but you can see that it's a little bit different. Still rather smooth, but you can see there's some bigger craters kind of off to the left up here. But this is basically where they landed. And the primary task of Apollo 12, which was the next mission, is to do more lunar exploration, basically, and deploy more experiments. So that's kind of the trend that continued over time with all of these Apollo missions, is that we decided we wanted to continue to send people there and to continue to do science on the moon, which is pretty cool. So basically, we furthered the knowledge of how humans can function on the moon with not even just deploying things, also how we move on the surface, how we function, and things like that, which is all pretty important. So their specific location is named the Ocean of Storms, which sounds really cool. So not a bad place. I'm just going to check the chat real quick to make sure we're doing all good. So I am going to talk about Apollo 13 real quick. Now, the interesting thing about Apollo 13 is that they didn't quite land on the surface of the moon. So they actually circled the moon, but they didn't land. And the reason because of that, they were supposed to land in a specific area. So we had it all picked out, but there was actually a rupture of the second oxygen tank on the where their spacecraft, basically where they were. And it caused a loss of normal supply of electricity, water, and light, which if you're that far away from Earth, that's probably really terrifying. So we did not land on the moon because of that, because it probably would have been really dangerous. Bad things would have happened. And so they just circled the moon and then came back and everything seemed to be okay. So even though we had that initial failure of something erupting or the oxygen tank having a rupture, we still call it a successful mission because it allowed NASA and the astronauts experience in dealing with really stressful situations, which is something that is very important when you're going to other planetary bodies, is that we need to be able to deal with stressful situations, think on our feet. So we still call it a successful mission because it actually kind of helped us practice with that. Although that's a scary practice run because if something went bad, I don't know. So I just wanted to talk about that guy real quick. Just checking the time to see how we are, to see what's going on there. Sweet. So I think I'm gonna go ahead and stop sharing and we can go back to the live view for a little bit and kind of give you guys a further update. And then I think we can maybe explain what an eclipse is again, just for people who might be joining the stream just now, so that they can kind of get a catch up on that. So we are, I think, experiencing a little more clouds currently. So you can actually see them in the Planewave or the Malencam software. So if you see what looks like these kind of like rippling features on the surface of the moon, it's actually just thin clouds passing forward. So that's what we're seeing here. So we'll keep you guys updated on our cloud situation, but so far it seems to be doing okay. We can still see the moon in good enough detail, so I'm pretty happy about it. So the moon has started turning red visually. It is a little bit hard to get in the Malencam without overexposing it. So I think I can even tell it is a little bit, just a tiny little bit less gray and maybe a little more on the red side. But it is hard to get some of that reddish color just because it is quite easy to overexpose on the specific camera that we're using, as you just saw. So yes. But Haley, did you want to quick explain what an eclipse is again, just so we have new people here?
Yeah, thanks. So for those of you guys who are just joining us, we'll talk a little bit more about what a lunar eclipse actually is. So a lunar eclipse happens when the moon passes into Earth's shadow. And Earth's shadow is broken into two pieces, a penumbra and an umbra. So the penumbra is kind of the outer edge of the shadow. It's a little bit lighter than the umbra is. And so there are actually three separate types of lunar eclipses. There are penumbral lunar eclipses, which is where the moon only passes through that outer edge of Earth's shadow, that penumbra area. There's a partial eclipse, which is actually what we're seeing on the moon right now, where it's partially in the umbra and partially in the penumbra. So if you look on our live feed right now, you'll notice that in our Malencam right here, the top left of the moon is kind of encased in that really dark, thick shadow there. And then towards the bottom, we're actually seeing the lighter shadow right there. That would be the penumbra. Now, a total lunar eclipse, which is what's going to happen between the hours of 4:11 a.m. and 4:25 a.m., so I guess minutes, not hours, and it'll peak at 4:18 a.m. That's going to be when the entire moon passes through the umbra. And so when that happens, we are actually going to see more of a redder color. So right now, the moon is a little bit redder. If you're looking at it from wherever you are with your naked eyes, you'll notice that it is a little bit redder. Like Claire was saying, it's a little harder to see it in our Malin cam right here without overexposing the moon, which is just where we're taking in too much light and it's way, way too bright. So, but if you look up at it, it is going to be kind of a redder color. And it looks like Claire is sending out the link to the JMars software, the one that she was using. Oh, and it turns out that once the moon is more and more covered, the Malin cam will actually start to see that redder color. So hopefully the clouds stay out of the way for us so that we can see that redder color as the eclipse progresses. So Claire, if you're ready, you can go back to talking about the missions you were talking about.
That sounds good to me. So if I could get screen sharing again, that would be good. So we could just grab that up real quick and I'll pull up that same software that I was using. Again, it's called JMars. If you just go to jmars.asu.edu, you'll find the main homepage for that. And that's where you can download it to whatever type of computer you have, basically. If I could grab screen share again, just to see if we can do that real quick. There we go. Sweet. So let me share my screen. There we go. So let me zoom out a little bit, let it get itself back together. And so there's actually another really cool thing that you can do. You can look at it in its 3D view. I think it's in another window for me right now. I need to move these guys out of the way. Let's see. I think it's up there. Maybe not. Let's get the 3D view going. So it might take a little while for that to load up, but the 3D view is kind of what allows you to look at the moon in its 3D version, so you can look at it in that orientation too. But I guess I can ignore that for now. So let's go to the next one. So after Apollo 13, we started with next one to Apollo 14, which actually is landed in the spot that Apollo 13 was supposed to land. So we can go ahead and go there. It is at 3.65 degrees south. And these coordinates I got based off of NASA's Apollo website, basically. So that's where I grabbed them, in case you were wondering. And then 17.48 degrees west. 17.48. Sweet, that should be good. So this is more in the highland area, I believe. So it's gonna be a little more cratered. We decided to go to slightly different places so that we can do some more interesting studies on the surface. So with Apollo 14, we did more lunar field geology. We did more investigations, collection of more samples, and the deployment of more science instruments. And this is jumping forward to 1971. So with the Apollo 11, we landed in 1969. But with here, we're jumping forward a little bit to 1971. So that's kind of the timeline that we are at right now. But let's go ahead and go to Apollo 15, which is, in my opinion, a little more interesting than Apollo 14. So we're gonna jump back to 26.08 degrees north. 26.08, and then 3.66 degrees east. Let's go there, see how this guy loads up. There we go. So it looks like we're in a little bit more mountainous regions now. So we have some more interesting geology to look at. And so this Apollo 15 is pretty interesting because it's the first Apollo J mission, which is basically more capability that we have accomplished with staying longer on the surface of the moon. This is where we actually started using the LRV, or the Lunar Roving Vehicle. So we brought some pretty cool toys to the moon to use, and this is kind of where we started it. And this is also where we upped our capability with actually staying on the moon. a little bit longer so that we could do some more cool science. And again, just basically increasing the amount of data and the amount of experience that we have on the moon. And I'll get into why some of this experience is important a little bit later when I talk about NASA's future plans for what we're going to do for the moon, because that's also really interesting. So all of these Apollo 11 missions, even though they seem like they happened a little bit of a long time ago, this is some of the most important data that we have for taking the next steps to continuing to go to the moon and then maybe even going to Mars in the future. So these are some of the really first important steps that we have been able to do. So I'm just going to check the chat real quick to see how we're doing. So question, is it true that humans are landing on the moon through the Artemis program in 2024? Well, that is NASA's plan so far. And so I think that is on track to go. Of course, sometimes with missions that are as important as that, especially with what we call crewed missions with actually using humans, we want to make sure that we have everything right before we actually go ahead and go on those missions. So it might be delayed, but I think that is about the timeline that we're looking for with sending people, the first woman and the first colored person to the moon, which is so exciting. So really cool things. So let's see, I'll show you guys one more Apollo 11 or Apollo 16 site, I should say. So jumping forward a little bit. So I'm gonna get the coordinates for this guy. It is 8.97 degrees south. Whoops, 8.97 degrees south. And then 15.51 degrees east. 15 and then 5.1. Whoops, just not delete the 6 there. Okay, should be good. Let's see what this looks like. So we're in a region called Descartes region, which is named after the philosopher René Descartes, who came up with a bunch of really cool philosophy, but that's not what I'm here to talk about. So this is another highlands region, so some of the oldest parts on the moon. And we're in the southeast quadrant right now, so I can zoom out a little bit. So we're pretty low south. If I go all the way out, we're basically down here in this region. So that's kind of where we're at here. So we, on this one, we're sampling new terrain and basically just continuing our science, but we're trying to pick different, more adventurous regions over time so that we can really get our science going and explore different aspects of the moon and how different regions are different from other regions and stuff like that. And so this is all really important science that is happening. Even though maybe to our eyes, the moon kind of looks the same everywhere, it is quite diverse. So that's why we picked a bunch of different places. But I think let's go ahead and see what we're doing with live view. It looks like we're having some cloud trouble, but we do have a cool explainer video that we can show you as well. So I'm going to stop screen sharing and let's at least check in with the live view first and see how we're doing there. But again, we might be dealing with some clouds, but hopefully those will move away before it gets to the actual total eclipse part. Yeah, it looks just a little bit cloudy. Sweet. Okay, so I think that's what our live view is. So again, hopefully those clouds will pass over pretty soon. And if you guys have any questions, keep them coming. We always love answering any questions that you guys have. But I think we have a video to show you if we're ready for that. Let's see.
What is a total lunar
eclipse? What we can actually do before I promise anything.
The Earth's shadow that is cast by the sun has two parts. The umbra is the darkest part of the Earth's shadow. If you're in the umbra, you can't see the sun at all. The penumbra is a much lighter part of the Earth's shadow. Here, only part of the sun is blocked from view. Whenever the Earth, moon, and sun line up, it is either a new moon or a full moon. This is called syzygy. If the moon's orbit around the Earth were in exactly the same plane as the Earth's orbit around the sun, we would see a lunar eclipse at every full moon. But the moon's orbit is inclined by about 5 degrees to Earth's orbital plane. This means that the moon continually cycles above and below Earth's orbital plane. If the moon crosses Earth's orbital plane at syzygy when it's full, this full moon enters the Earth's umbra completely, and we get a total lunar eclipse. If the full moon is a bit further from Earth's orbital plane, only part of it enters the Earth's umbra, so we get a partial lunar eclipse. If the full moon is further still from the Earth's orbital plane, it misses the Earth's umbra, but still passes through the penumbra. This is what we call a penumbral lunar eclipse. During most full moons, the moon passes above or below the penumbra altogether, and there's no lunar eclipse at all.
All right, so I think we're all finished up with the video, so hopefully that was a nice little diversion. So if we go back to the live view with the Malin cam, we can kind of start to see some red, although there is a little bit of cloud. So kind of like right in that middle where the divide between the shadowed parts that are pretty heavily shadowed right now, and then the lighter parts, you can start to see just a little bit of glimmer of red in there, which is pretty exciting. But I also want to remind you guys that we have a second live view on the right of the screen, and that is from our Vixen refracting telescope. So it is a nice wide field view. Be sure to glance up there every now and then. It might offer a slightly better view. So just personal preference if you like, but just want to remind you guys that we have two different views going on and stuff like that. So we're coming up a little bit more towards the actual total eclipse. So again, that will be happening just after 4:00 a.m. in the morning for us here in Flagstaff. So we'll be continuing to see the moon turning a red color, hopefully if the clouds stay at bay. And we're crossing our fingers for that because we want to see this really cool eclipse happening. So yeah, so again, if you guys have any questions, feel free to keep asking those. But I figured I could take a little bit of time to talk about some of the current research being done on the moon, and also talk a little bit more about Artemis, which is again sending humans to the moon for the second round, basically. So I will go ahead and talk about that. So there is one really cool mission that we're planning that doesn't have to do with a crewed mission at all, and it's something called the Viper mission, and Viper stands for Volatiles Investigating Polar Exploration Rover. So acronyms are always really fun in planetary science or astronomy as a whole. So it's called Viper, and basically what this spacecraft is going to be doing is hunting for water on the lunar surface. And so right now, as a pretty current update, it's starting to be built. So we have a specific clean room for it. And the reason that we use clean rooms for building spacecraft is that we don't want to accidentally get our bacteria and send it to another planetary body and potentially infect in a way that planetary body. So we try to be really careful with that. And that's why we use specific clean rooms. We have like protocols and stuff in place for building these types of spacecraft in the most sanitary way possible, which seems pretty safe. So it is currently has a clean room. It's continuing or beginning to be built. And I think that is coming up in the next couple of minutes. I think Haley talked about this a little bit earlier, but there's an interesting thing with tardigrades. I don't know, this might be a good time to mention that. So if you want to talk about that real quick.
Yeah, so one of the missions to the moon, it actually had a bunch of little tardigrades on it. So tardigrades are some of the smallest, most resilient organisms we find here on Earth. And we wanted to see how they would act on the moon, right? How they would kind of how they would respond to the moon's atmosphere, well, lack of atmosphere, really, and lack of gravity. And so we took the tardigrades out, and it actually turns out that the mission or the spacecraft that had the tardigrades on it, they actually crashed. It crashed on the moon and spilled tardigrades everywhere. And so the great thing about that is that there are aliens because we put them on the moon, right? Tardigrades were life forms off of the moon for one point in time, and they were living there. So a lot of people joke that we have found aliens because like we're the ones who dropped them on the moon. So that was something really interesting. It's something that I really like is the fact that these tardigrades were just like crawling all over the moon, and they survived there for a hot minute. Like they were there for a little bit. So that was pretty interesting. And yeah, so it looks like we want to remind you guys that yes, there are quite a few clouds right now, which is why we're not seeing a whole lot on our live streams. And the other reason we're not seeing a whole lot is because we are getting pretty close to the total lunar eclipse. And so the light from the sun isn't refracting off of the moon very well, or for like most of it, right? It's passing into that Earth shadow there. And so the moon is just kind of gonna look like a tiny little blob for a while, but hopefully, crossing my fingers, hopefully these clouds will pass so that we can get you guys some good views of the total eclipse that'll happen around 4:11 a.m. Flagstaff time. So that would be really, really nice. But yeah, so speaking of things walking on the moon, I have a really cute video for you guys. It's a video I found that is a bunch of astronauts walking across the moon. And so I'm gonna go back to my little PowerPoint that I have right here. And we're gonna take a look at this video. It's one of my favorites. So let's see, where did it go? Here we go. So we have, come on. Why does it keep doing that? Let's go.
The fact that it's a vacuum out there, and if you spring a leak next to it, you're gonna be dead. Uh-oh. Maybe landing. Boy, do I like to run up here.
So that's one of my favorite videos. So it just shows that these astronauts, they're out there having a great time. I mean, they've trained so hard to go up there. This is like the peak of their existence, right? Going up there and walking on the moon, which is really fun. And I use the term walking pretty loosely. So you'll notice that they weren't actually walking on the surface of the moon. They were more so like bouncing across the surface of the moon. And that has to do with the moon's gravity. It is much, much less gravitational than Earth is. And so walking on the surface of the moon, like you would walk here on Earth, right? Like bending your knees, walking forward and everything, that is going to take a lot more energy than just bouncing around on the moon would. And so these astronauts, they trained to bounce around on the surface of the moon. So you noticed that like when they fell, they had to do this little like push-up thing where they got up that way. And I just think that's like the cutest video out there, right? Just these astronauts walking around, having a fantastic time with one another, laughing about falling and everything along those lines. So I think that's pretty cool. But yeah, so that's a little bit about walking on the surface of the moon, what it might be like. And we've got our Malin cam back up, and as you can see, the moon is still a little bit of a blob. We still do have quite a bit of cloud cover, but you can see that faint glow on the side there and the dark shadow on the other side. And so you're seeing that the Earth shadow, that umbra, is coming across the moon pretty quickly now. So you can see that it's really starting to move over. So, and by the way, if you guys have any questions, please drop them in the chat and we'll answer them at any point in time. But yeah, so Claire, did you have any more about the missions to the moon that you'd like to share?
I do, yes. And so there's quite a lot happening in the future. So not only are we planning on sending just regular like spacecraft, like unmanned things such as like little landers basically on the surface to do remote science, kind of like how we do with Mars currently. So NASA just launched the Perseverance rover, and it landed on Mars back in February. And those are really important because currently we have not been able to send humans to Mars. That's the goal, and I'll talk about that in a moment. But we think about the science that we want to do and create a specialized spacecraft or specialized rover for the surface, and it does all the science for us remotely, which is pretty amazing that we've been able to figure that out and create the technology for that. It's all really cool. So we're going to continue to send things like that to the moon in order to just get a little more data about what the surface is like. Basically, the more data, the more science we have, the better we can understand how humans will be able to function on the moon and what our capabilities are. So those are all really important, and those will continue to go basically from all countries around the world. So in the next couple years, and especially in 2021, it looks like when I checked a little bit earlier, there's quite a lot of missions to the moon planned, not only from the USA, but from Europe, from China, and from Russia as well, which all of these countries are wanting to send their own spacecraft there, which is pretty amazing. So hopefully we can do some cool collaborative science with that. But the main mission that I want to talk about is called Artemis, and it's named that because Artemis is the twin sister of Apollo. So Apollo, the first missions that we sent man to the moon. Now Artemis this time, kind of the same idea, but this one's really cool because we're supposed to send the first woman and also the first person of color to the moon, which is a really important step. And I think that will be really exciting to try and get some more diversity in terms of the scientists and the people that we send into space. So that is planned for the next coming years, and I believe when we're starting to do the crewed missions or the manned missions for these, that will start in 2023, and then we're supposed to land actually on the moon in 2024. So we're going to kind of do something like what we did with the Apollo missions. So right before Apollo 11, that's when we actually landed on the moon. We sent another mission right before it, and that mission basically did everything except landing on the moon. So we're going to do something similar with Artemis, where we do everything kind of as like a trial run, except actually landing. So that will happen the year before we plan to land on the moon. So it looks like we have a question. Is SpaceX involved with these plans, or is it just NASA? I believe SpaceX is involved in sending some of, or using some of the rockets for stuff, and also sending some of the like parts that we need to actually help people land on the moon. So we're doing it in a slightly different system than what we did with Apollo. So what we're using for lunar landers, so the things that will actually land on the surface and help humans to get there, SpaceX is actually creating an HLS Starship, and we're using specifically that. And NASA's already announced that we are using SpaceX for that. So we are using commercial spaceflight, which is kind of exciting because it opens up the possibilities of what NASA can focus on. So NASA doesn't necessarily need to focus on every aspect of the journey to the moon. We can also have other very creative and like really well-minded people who also work on this mission and kind of put all the pieces together so that not only can we do it faster, but we can do it in more creative ways. And we can collaborate a little bit more, which is something that's really exciting. So commercial spaceflight is going to have a bigger role in these Artemis missions, which is pretty cool. So there are a couple steps that NASA has to go through, and it's quite a lot, of course, because sending people to the moon is not easy at all. But there are basically phased stages of this Artemis program. So what we're starting with is that we are expanding our ground system. So basically the Space Launch System, the Kennedy Space Center in Florida, we're kind of upping the technology there so that we can actually have a new place to launch. So we want to have the safest, the most new, the most technological place that we can actually launch these rockets from. So that's one of the first parts, is that let's get the things on the ground first going before we think about actually getting things up off the ground. So we need everything there to kind of be figured out. But the next part is the Space Launch System, and that is basically just an extremely powerful rocket that can take us to the moon with humans on it, and with a bunch of other stuff like food and water that is really important. So basically the next part, Space Launch System, is just the actual rocket itself. But the next part after that is called Orion, and it is the spacecraft for the actual lunar mission. So it's a little bit different from the rocket itself. It'll carry the actual crew into lunar orbit, and then they will transfer to something that NASA calls the Gateway. And that's where they'll actually be able to land on the moon. And Orion is also where they will come back to that after landing on the surface and then come back to Earth. So it's where they go to the moon and then exit the moon as well. So the Orion spacecraft is really important here. And then I mentioned the Gateway just a minute ago. So that is what they call the lunar outpost around the moon. And this is actually a model basically for what we're hoping to use when we potentially send humans to Mars for the first time. So the whole idea of Artemis is not only to get people back to the moon, but also to really test what we can do to potentially send people to Mars. So this is kind of like the trial run that is a little bit closer to Earth. So we can figure things out here, closer, at least with the moon, is a lot closer than Mars, at least. And then we'll use some of this technology, use what we learned from the Artemis missions to go to Mars with their first humans there. So that's what it's kind of doing here. And then we have the lunar landers, which will actually land on the surface, and that's where SpaceX is at least officially involved right now. And then we have, what's kind of cool is that we're coming out with a new spacesuit, so I'm excited to see what they look like. But maybe they won't be quite as marshmallowy as the Apollo 11 astronauts were, maybe a little more functional, but again, it's kind of hard to do because you need to keep lots of pressure in, you need to be able to breathe. But I'm excited to see what they look like. Maybe it'll look more like what the spacesuits are like in the movie The Martian or something like that. But who knows? That's NASA top secret stuff that I don't even know. So exciting things to see. So it looks like we have a question. Can anyone see it in Phoenix, Arizona? So you should be able to at least see it. I have no idea if it's cloudy there right now. So I'd have to check the weather specifically, but I don't have a particular answer for that just because I don't quite know what the weather is like. So it looks like right now we have red in the live view when there's not clouds, of course. So you can kind of see that there is a little bit of a red shade to the moon, kind of coming through those clouds passing over. I know it's a bit hard to see, but we can kind of see it a little bit. Yeah, you can kind of see that red color, which is nice. Doesn't look quite as gray as beforehand. Let's see. Yeah, so that's the Artemis mission, and it's supposed to be kind of like an analog for us going to Mars, which is really exciting. We don't exactly know when we're going to Mars. I haven't heard of a specific timeline of when we exactly think, at least for NASA. SpaceX and Elon Musk have set their own timelines, basically, but this isn't necessarily what NASA is following. So there might be two separate timelines to kind of keep in mind. So far, NASA hasn't officially announced when they're at least trying to put people on the surface of Mars, but they have announced when they're trying at least for the surface of the moon, which is in 2024 again. So something to keep a lookout for. That's coming up pretty soon, which is exciting. And over time, I'm sure we'll hear more about how we're going to land on the moon. And I'm really excited to actually be able to see a live landing on the moon because I was too young, of course, for the last one. So I'm very excited for this. But sweet. So I'm going to hand it over to Haley, and she's going to talk about the difference between phases of the moon in eclipse. So it's kind of an important aspect that many of us might not think about straight away, but Haley can do a great job explaining this. So I'm going to hand it over to her real quick, and she can explain that for you guys.
Cool. So I know that we didn't get this question in the chat, but my roommate earlier today actually asked me what the difference between these two were. So I figured if he's confused, maybe some other people might be a little confused. So I like to go over what the difference is. So before we can talk about the difference between moon phases and eclipses, we first have to talk about how the moon physically orbits around the Earth. So the moon orbits around the Earth, and it is it's something called tidally locked. So basically, tidally locked means that we always see the same face of the moon, night to night. Whenever it's a half moon, whenever it's a 3/4 moon, it's always going to be that same side of the moon. The other side is called the dark side of the moon, right? Because we can't actually see it from here on Earth. So as the moon as the moon orbits around the Earth, the sun is still in the middle. And so that sun is going to be shining on the moon. So the moon constantly has one side lit up and one side dark. But the lit up side and the dark side might show up partially from here on Earth. Right. So as the moon rotates around the Earth, various different parts of the moon are going to be visible when it comes to like daytime, nighttime side. Right. That's what we like to call them. And it's actually really funny. The difference between the daytime and nighttime part of the moon, we call it the terminator. So that's what splits the daytime, nighttime side of the moon. And so that's what causes the phases of the moon, right? As the moon orbits around the Earth, we start seeing different amounts of the daytime side versus the nighttime side. So for example, on the new moon, we see just the nighttime side of the moon, right? It's completely dark. But on a full moon like tonight, we see entirely the daytime side of the moon. So that's where the sun is shining fully on the face of the moon. And that is why lunar eclipses can only happen on a full moon, because on a full moon, that's when the moon is farther away from the sun, where the sun is actually shining on its face and the Earth will get straight between the two. So a lunar eclipse can only happen when the moon, Earth, and sun are all on the same plane. So the moon orbits around the Earth at a slight tilt, right? A very slight tilt. And so as the moon orbits around the Earth, it's not always on that same flat plane. Only about once or twice a year does it meet perfectly on that same flat plane. So that's the difference between phases of the moon versus a lunar eclipse. And just a reminder that we are getting real close to the full lunar eclipse. It'll happen at about 4:11 a.m. until 4:25 a.m. And looks like, yeah, so I have a question. Will we ever see the moon completely covered? So ideally we will. That entirely depends on the clouds. So if the clouds clear up a little bit, we will actually see the full moon being covered, and it'll have that redder color to it. So hopefully it'll make it through the clouds, but once it gets all dark, you can see that we've been trying to up the exposure, trying to show that brighter part of the moon. Once it completely passes over, it will be a little bit harder to see. But if you look, you can actually see in the mountain cam that redder color. So as the moon is getting closer and closer to totality, you can start to see that redder color there. So yeah, that's a little bit about the difference between phases and eclipses. And Claire, do you have some more fun mission facts for us?
I can't certainly talk about mission facts, but I do want to talk about one thing, is why total lunar eclipses create a red color on the moon, because it's like, why does that even happen? The reason for that is that as light is passing through our atmosphere and creating a shadow on the moon, Earth's atmosphere actually filters out a lot of blue light. It filters out and scatters lots of blue light. And so that leaves red light to just keep passing and actually reach the moon. And so that's why the moon usually gets a nice red color to it. And it is also why when we're able to look up at the night sky when a total eclipse is happening like this, so the moon will appear really red, but also our sky, or the sky around it, will appear a little bit more blue. And that's all based off of how the dynamics work in our atmosphere, simply because our atmosphere, again, filters and scatters blue light a little more easily, and that red light is able to pass through. So that's how we actually get the red color of these total eclipses. So yeah, that's most of what I had about that. We're still trying to fight the clouds, and we're getting a little bit closer again just to that total eclipse. So keeping our fingers crossed that we'll have just a brief little opening that we can actually see a nice clear view of the moon. But be sure to still check out that little one kind of on the top right of your guys's with our Vixen. See how that guy is doing up there as well. Sweet. So I can talk a little bit more about mission stuff if you guys would like. So besides Artemis, which is kind of the main thing that we're doing, there are a lot of other current there's a lot of current science being done on the moon. One of the main things that the USA is using right now is something that we call the Lunar Reconnaissance Orbiter, which is where we get a lot of our data nowadays. And when I was showing JMARS earlier, that's actually from the global map that we have been using. So that can create high detailed maps for us, and it can help us basically just know overall what the dynamics of the surface are like. And another really cool thing is that here in Flagstaff, we actually have part of what we call the USGS, which is the United States Geological Survey. And that may seem like they just focus on stuff here on Earth, but that is untrue because they care a lot about planetary science. And so the USGS works a lot on mapping the moon and figuring out what type of geology is on the moon. So another cool thing with JMARS is that you can actually load up a layer that it has to do with the USGS, and it's like a total geological survey. And it basically just shows you all of the geological features on the surface, what ages they come from, how they interact with each other, and things like that. And it's a really cool map to look at because, again, to our own eyes, the moon may seem incredibly boring, but there's actually quite a lot going on, and there's a lot of history that we'd love to figure out as well. And so I know this was a headline a little while ago, but there is a really cool aspect of the moon that we have just figured out. So there is a spacecraft called Sophia, and that spacecraft actually found water on a sunlit surface of the moon. And that's important because it brings out the possibility of water being more prevalent and distributed on the surface. So that's really cool. So water may not only be delegated to icy and cold regions where it would be ice, but it can actually be in sunlit regions, which is really cool for potential of water on the surface of the moon. So we do know that there is water, at least just a little bit, on the surface of the moon. So I do use a little bit, very potentially, because it is not a lot of water. So the section that we looked at with Sophia is we think that in the equivalent amount is only about a 12-ounce bottle of water in like this section of the moon, which like isn't that much. You can buy that at the grocery store for like 50 cents or something. So like not a lot of water on the moon, of course, because we don't see these nice flowing oceans on the surface, but we do know that water does exist. And with Sophia in specific, in the early stages of this year, we did figure out that it could potentially exist in more prevalent areas, in sunlit areas, which is really exciting. And so stuff like this from spacecraft, from space-based telescopes, from even telescopes here on Earth, all of this new science keeps coming out. So we may think that we're kind of done looking at the moon. We know all there is to know. The moon is boring. We kind of know the dynamics already, but we still know, still don't know so much about the moon, and we keep figuring that out, and it's all really exciting. So keep your eyes out for new lunar science, because I'm sure it will be very, very exciting. So just to keep that in mind, let's see. So we are about 15 minutes away from totality. So again, 4:11 a.m. PDT, or basically our time here. So pretty close, just over 10-15 minutes away. So keep that in mind. So you can see through the Malankame, even though we are still dealing with some clouds, you can see that that red color is becoming a little more intense. It's despite the clouds coming through more clearly than it was before. So we are definitely nearing the total eclipse. So that's pretty interesting. So I'm going to hand it over to Haley again, and she can talk about the difference between solar eclipses and lunar eclipses, because that's a good distinction to make for sure.
Yeah, thanks, Claire. So the main difference between solar eclipses and lunar eclipses is the order of the sun, earth, and moon. So a lunar eclipse happens when the earth is between the sun and the moon. So a little bit of reiteration for those of you guys who are just joining us. There are 3 different types of lunar eclipses: a penumbral, a partial, and a total lunar eclipse. So the Earth, it casts 2 shadows. It casts a thinner penumbral shadow and a darker umbral shadow. So a penumbral lunar eclipse is when the moon just passes through the penumbra, right? That lighter kind of shadow that the Earth is casting. A partial eclipse happens when the moon passes slightly through the umbra as well. So we actually had a penumbral lunar eclipse that started at 1:47 a.m. here in Arizona time. And then the partial eclipse started at about 2:44 a.m. and it is still going on right now until 4:11 a.m. when the total lunar eclipse happens, which is when the moon will fully pass through that umbra, that darkest part of the Earth's shadow. So the difference with a solar eclipse is that instead of the Earth being between the sun and the moon, it's actually the moon that's between the sun and the Earth. And solar eclipses happen fairly frequently, probably a little bit more often than lunar eclipses do. And there are different types of solar eclipses, just like there's different types of lunar eclipses. So obviously, the moon is much smaller than the sun. And so depending on where Earth is in its orbit, sometimes it's just right to where, from our point of view, the moon and the sun look about the same size. And so when that happens, we can actually reach a total solar eclipse. So the last one that passed over the United States happened back in 2017. We did a really big event up here at Lowell. It was super fun. I worked that day and it was just so cool, even though it was only 75% totality here in Flagstaff. So the moon didn't fully pass over the sun. It was still a really amazing thing to see. And in certain regions, it was a total solar eclipse. Now, the next total solar eclipse is actually going to happen in 2024. So that's going to be a really interesting year, 2024. So if you guys are looking forward to that, I would try to find some solar glasses now while you can, because I remember last time we actually ran out of solar glasses about a week before the eclipse happened. So definitely try and find some of those before that happens again. But yeah, so solar eclipses, they happen fairly frequently across the Earth, and they're only visible in certain parts of the Earth, right? So if you live somewhere other than Arizona, or somewhere maybe south of the border or something along those lines, or south of the equator, something along those lines, you're gonna see different solar eclipses, right? So you can actually look up when the next total solar eclipse near you is going to happen. So I'm getting a couple of messages in the chat. It looks like the Vixen lost the moon entirely. It's looking like the Melancam is as well. However, it does look like the Lowell Discovery Telescope Night Watch is showing that hopefully the clouds will break up a little bit. So that would be really ideal, but I'm not entirely sure. I wish I could control the weather. I would make it as clear as we could tonight if I could do that, but unfortunately, that's not really within my powers. But yeah. So, it's looking like there's certain parts of the night sky that are a little less cloudy, but unfortunately right now where the moon is quite clouded out. So it looks like we have a video for you guys because that total solar eclipse is going, or solar eclipse, the total lunar eclipse is going to happen very soon. So we're going to show you guys a video to remind you guys what you're looking for. So go ahead and play that.
What is a total lunar eclipse? The Earth's shadow that is cast by the sun has two parts. The umbra is the darkest part of the Earth's shadow. If you're in the umbra, you can't see the sun at all. The penumbra is a much lighter part of the Earth's shadow. Here, only part of the sun is blocked from view. Whenever the Earth, moon, and sun line up, it is either a new moon or a full moon. This is called syzygy. If the moon's orbit around the Earth were in exactly the same plane as the Earth's orbit around the sun, we would see a lunar eclipse at every full moon. But the moon's orbit is inclined by about 5 degrees to Earth's orbital plane. This means that the moon continually cycles above and below Earth's orbital plane. If the moon crosses Earth's orbital plane at syzygy when it's full, this full moon enters the Earth's umbra completely, and we get a total lunar eclipse. If the full moon is a bit further from Earth's orbital plane, only part of it enters the Earth's umbra, so we get a partial lunar eclipse. If the full moon is further still from the Earth's orbital plane, it misses the Earth's umbra, but still passes through the penumbra. This is what we call a penumbral lunar eclipse. During most full moons, the moon passes above or below the penumbra altogether, and there's no lunar eclipse at all.
Awesome. Well, I hope you guys enjoyed that video. So we are just under about 7 minutes away from the total lunar eclipse that's about to happen. So I don't know if it's just the Malin cam or if it's the moon, but I do see kind of a red tint. So hopefully it's the moon because it is going to start looking really nice red color. So hopefully where you guys are, you can see the moon with your naked eye. If not, you can actually see this reddish color coming through the clouds right here on our Malin cam. So very exciting, very exciting. Like we said, total lunar eclipses maybe happen about once or twice a year. Total lunar eclipses that on a supermoon typically only happen maybe once or twice a decade. So this is definitely a really, really interesting thing to see. Oh, and it looks like there's a window in the clouds that's headed our way and from the southwest. So, oh, wow, look at that. Oh, that's so exciting. Look at the beautiful red right there. So you can see there's just a little bit of white on the side there. So it is really coming through, right? That beautiful red color. This is really exciting. I mean, obviously I'm excited. I hope you guys are too. But yeah, so we're seeing that brighter side of the moon. That's where the moon hasn't fully passed through the umbra yet. So it will in just a few minutes here, which is going to be a super cool thing to view. I hope all of you guys are having a little better luck than we are right here. But hopefully it is as nice on your guys' screens as it is on mine, because this is just a gorgeous red color right here. So
I with the clouds, at least, I kind of love the pink color that it's giving off. Like, it's kind of like an interesting twist that we have going on, kind of creating that nice pink color with the red, but that's just my input. So exciting to see.
No, yeah, I totally agree. The pinks that we're getting in here, the reds, it's all very pretty. And the totality is going to happen in 4 minutes. So that entire white part on the right edge of the moon is just going to be completely gone. And it's just going to be this really rich, beautiful red color across the surface of the moon, which is going to be super cool. And oh, you can even see we're starting to get a little bit of the Maria coming back through. So we're going to start getting a little more definition on the moon. You can see here, oh yeah, that was a really good spot. So it looks like those clouds are moving pretty quick. So hopefully we'll get a really nice view in the next couple minutes, because it's about to happen. Yeah,
we're so close. This is very exciting.
Mm-hmm.
Glad I stayed up until 4 a.m. to do this. Usually I don't do that, so.
Yeah, absolutely. This was definitely worth it, especially with this nice little window we're getting here where we can see a little bit of the definition on the surface of the moon. We are trying to get the moon in our Vixen telescope, the one where you can see the full view of the moon. It is a little bit smaller, so the moon is a little dim, so we might not be able to get a whole lot of good viewing out of it. But this view on the Malin cam, I mean, it's more than I expected, right? The cloud coverage was supposed to be really, really bad by now, so it's looking a lot better than I expected.
Yeah, we were all a little apprehensive of the weather. I at least was obsessively checking the weather every 10 minutes this entire day, just being like, open up at 4 a.m. just for a little bit. It seemed like it kind of worked, so I'm pretty happy about that. Yeah, we can definitely start to see some of those surface features coming in actually pretty nicely. And it looks like it's continuing to improve over time, which is super awesome for us. So we're about 2 minutes away. So just keep that in mind. So we're nearing the actual max eclipse, which is super exciting. So keep a lookout for that. Continue to see the moon change just a little bit more probably. And then after that, we'll exit the total eclipse. We'll kind of go the opposite of what we've been looking at this entire time. So that's kind of what will happen next, but still got about 2 minutes left. So we're changing the exposure time just a little bit so we can get you guys the best view. Again, it's pretty easy to overexpose. We're trying to get the best color for you guys right now because that's the most exciting thing to see. Again, this is a blood red eclipse, so we really want to get that color for you guys. And it's coming through really well. This is a great color. It's amazing. Yeah, this is probably about good. So it might be a little shiny on one side, but we can still get some really good color. And it looks great to me, so I'm excited about this.
Yeah, I think we got 1 minute till the start of the total lunar eclipse. So pretty soon here, that really bright spot on the side is going to be pretty much gone, and we're just going to see this full red color across the moon. So you can see with the exposure down, it's just that tiny sliver of moon that's still outside of the umbra. And the max of the total eclipse is going to happen at 4:18. So that's about 8 minutes from now, which is going to be pretty fantastic. Very exciting stuff over here. We're seeing all of those Maria in there. So earlier I talked about how Maria are basically seas of cooled down basaltic lava rock. So stuff that we find here in Flagstaff, because Flagstaff's actually an inactive volcano. And so those dark spots are really coming through here through the clouds, which is really nice. So hopefully as this progresses over the next couple minutes, we will start seeing a little bit more. But you can see here, look at how it's getting darker right now. That's because we have officially started the total lunar eclipse. So even with it being super duper exposed, we've got less of that bright spot on the side there because the whole moon is inside of the umbra of the Earth's shadow. So there's a very large cloud coming through, but we are getting some nice red in there. You can see as the cloud overtakes the view, those last shreds of red really trying to puncture through that cloud.
We still got 8 minutes, so we should hopefully maybe get another small opening that we can see a nice, good view again. So hold out until then, because we still have some time left. So
yeah, that would be pretty fantastic. This is going to be pretty cool. Yeah, so this totality, it should last through 4:25 a.m. So that's a little over, what is that, like? That's about 13 minutes from now. So we've got about 13 more minutes of this totality. So we're really hoping, putting those good vibes out into the universe. Oh, look at that. Look at that. Oh, wow. Oh, I'm actually speechless. This is so pretty. This is an old image we took a little bit long ago, a little snap that we took of the moon right before totality. So you can see the difference between this and then if you want to go over to the video and that. So we've got a really nice, beautiful image that we took, which is super exciting because even if we don't get out of this cloud, we've still got these really, really pretty kind of pinkish red images that we've got here. But yeah.
Sweet. And I think we're still trying to find it through our Vixen telescope, but that one we move with our own hands and use our own eyeballs to look at it. So that one can be a lot harder than just using a computer to find the moon, especially if it's really clouded out like we're seeing right here with the Malacam. It's probably hard to find with your naked eye. So we're trying our hardest with that. But let's see. Yeah, I think we're going to keep trying for that. Again, it's just kind of hard to point the telescope when you can't really see the moon all that well with your naked eye. So I think we're just going to keep on checking in on that. Yeah. So let us know what you guys are able to see in your own location, wherever you are in the world, because I know we have lots of people from everywhere, which is very exciting. So let us know what you're seeing in your particular little place. Always fun to see what other people are up to. And we're trying our hardest here in Arizona. So thanks for sticking with us, though. So we can still, the clouds are kind of coming through, but we can definitely still see some of that color on the side, and we can definitely tell that that side is fully in shadow now. It's not as overexposed. So that is a new detail that we can see. So we are definitely within total eclipse currently, and we still have lots of more time on that. And so when, oh, go ahead.
Oh, I was just gonna say, yeah, and while we're trying to get this through the clouds, I'd like to take a second and thank you guys for coming to our stream. I mean, it means the world to us that so many of you guys wanted to join us here at Lowell, seeing this really fantastic event happen. I mean, I'm honored to be able to talk to you guys about all of this, and I really like being able to show you guys all of these images. Even if it is cloudy, you know, we can take a look back at when the moon wasn't fully in its shadow, in Earth's shadow. But yeah, and I just like to thank our whole crew that's going on. We got quite a few people operating the telescopes for us, checking out the chat, looking at the live stream, making sure everything's in place. So I want to thank everyone for helping us out here. But yeah, hopefully within the next 10 minutes we can get some more really pretty views for you guys. So
yeah, definitely. Yeah, I'm excited to see what comes. I still have hope that we'll have a couple pockets in the clouds that we can see some pretty good views with. So right now we're still on that snapshot right now from just before total eclipse, but I think we can try to move back to what we're doing, or the live view, to just see the update. It's just kind of on the edge right there. We are taking a fairly long exposure, so 3.4 seconds, trying to get as much light as we possibly can to try and see some color. So we might be continuing to increase the exposure time because of that, so we can try to bring some light in through those clouds as best as we can. So that's kind of what we're playing around with right here, trying our hardest. We can also, what we're doing right now is increasing the gain, or basically the sensitivity of the camera. And that can help us out too. So we have two main settings. So it looks like we're starting to get a little bit kind of on the edge, but might just be a small little pocket in the clouds. So we're still trying kind of hard. Yeah. So now we're going to try to move that bit of the moon maybe into more center view so we can see it. Sometimes jogging the telescope can be hard. And that's what we're doing, is we're just moving the telescope in very small little segments so that we can look at a specific section of the moon. And so I think that's what we're doing here.
Yeah, and I'm hoping these clouds pass by here quickly, because it looks like we are getting close to the tree line up here in Flagstaff. So pretty soon here, the moon will actually pass below our trees where our telescopes are. So we'll be getting even less light in. And then once it hits the thicker part of the trees, we're getting like no light in. So I'm hoping within the next couple minutes here, the clouds will move over a little bit. But even if they don't, like I said, we've got these really great images from when it was even just like very close partial eclipse, right? These really nice images where you can see a lot of the details on it. But unfortunately, it looks like our Vixen telescope, the one that we move by hand, try to point it around. We're actually going to have to call it on the Vixen, just because we can't actually see the moon to point it. The nice thing about our Planewave, the one that we're using for the Malin cam right here, is that it tracks for you. So there was actually a software that they pulled up a hot minute ago, but you just click on the object and it'll move over to it. And we like to call our Planewaves ninja telescopes, because when they move, it's so quick and so quiet. It's such an interesting thing to see. But yeah, we have our Planewave software that we pull up, and we use it to like move the telescope around rather than having to look. Oh yeah, down at the bottom there, you could see the Planewave instrument software. Yeah, that guy right there. But with the Vixen, you have to be able to like physically see the object with your eyes. But yeah, Planewave interface right here, this is how we move the telescope around. So one of these just popped up full screen, but yeah, it's basically like a big picture of the night sky where you can click on something, and the Malincam, the Planewave that the Malincam is attached to, will actually kind of slew over. You just hit that little go-to button and it'll move over to the moon in this case, or you can stop it if it's not going quite where you wanted it to. And that's also where that jog function is, the one that Claire was talking about. Yeah.
Yeah. Sweet. So again, we're still trying hard to get some of that live view in. But again, the clouds are being a little bit picky right now with where they're going in the night sky. It looks like we kind of just lost it in the trees. So not sure what else we'll be able to do in terms of viewing it, but we'll still try as much as we can. But again, with Flagstaff, we have many trees around us, all ponderosa pine trees, and it's all really important to our forest, so we don't necessarily want to cut them down, but sometimes they are a little bit annoying for astronomy, but just have to deal with nature sometimes. I guess that's the way it goes. So yeah.
And it looks like we got a question of why is it pink? So the reason it's pink is because this moon right here, it is passing through Earth's shadow. And as the sunlight comes through Earth's atmosphere, it actually refracts, it bends the reds in such a way that we're actually just seeing these red wavelengths across the surface of the moon. So it's kind of like moving all of the blue wavelengths a little bit. And so we're seeing that the shadow cast is actually kind of a reddish color as it goes through that thicker part.
Yeah, and another cool way to think about it is that besides just kind of ignoring that blue light, we're actually seeing basically the colors seen at sunrise and sunset projected onto the moon, which is like a really cool way to think about this, is that we're kind of like seeing a sunset just like projected on it, which is really cool to think about. So that's another way that you can think about it as well. Another reason why it's also kind of red is that it's quite low to the horizon, which will also kind of increase that, how we're actually viewing it through our atmosphere and how red that it actually gets. So the lower to the horizon, the greater color that we can usually see with that. So it is kind of doubly red in a sense because it is quite low, hence behind the trees for us. So
yeah.
Yeah, that's all good questions.
Oh, there was an airplane in the Vixen, if you guys caught that. Not space aliens, unfortunately, but yeah, that's apparently cool. It looked cool. So hope you guys all caught that.
Yeah.
Yeah.
Yeah, I think actually one of the last times we did a stream, I think with the conjunction when Jupiter and Saturn were getting real close to each other, I think we also gotten a really cool airplane shot with those. I remember that happening, which was really cool to see. So.
Yeah, that actually happens quite often when we're looking through telescopes. We'll get like airplanes through them or satellites. I've seen quite a few satellites in there. Yeah. It's very, very rare, but if you're super lucky, you might even see a shooting star through the telescope. So in my opinion, you should like make 2 wishes on that star, right? Because not only did you see it, but you saw it like through this little telescope that shortens the field of view. Oh, it looks like the Vixen's got the moon. Does the Vixen have the moon? Yeah?
Maybe.
That's awesome.
Something.
Well, I'm glad you guys got to see it.
Just a little bit.
Yeah.
Just a little bit of the moon.
Barely, but it's there. Hey. Yeah. Little guy didn't quit on us yet. So
very true.
Yeah, our Vixen telescope, it's a smaller telescope than the Planewave. So it is it has like a wider field of view, and it's a really great telescope. We actually like to take it on our offsites. So Lowell Observatory will actually go out to like weddings and star parties and such, and we'll bring the Vixen and maybe one of our like 12-inch telescopes as well. So it's a really, really fun little telescope, and it travels pretty well. So it's a good little guy.
Yeah, it's, I guess, probably one of my favorite telescopes that I actually have to move with my own hands, which isn't something that we do that often anymore, because now most of the telescopes that we use up at the Godo deck, our Geo Valley Open Deck Observatory, are all computerized. We actually have specific iPads for each one. So we just press on an object, click go to, and it'll move itself, which is like totally fancy and awesome to see. But kind of makes us have to practice those portables with our own hands a little more, because we don't use it as often, but kind of fun.
Well, it looks like it is 4:25 a.m., which means that the totality is ending for us. So that was a nice little area where we had that full totality. Unfortunately, we didn't see a whole lot of it, but it was pretty, even though we could only really see the red color, and every once in a while we got some of those dark Maria. But yeah, that is the end of the totality, and it'll go back into a partial eclipse, continue on, and go kind of backwards from where we started. So that right there is a tree in the video, the Malin Cam video. So I think we have officially lost it in our Malin Cam, but here is a pretty fantastic picture that we took earlier on. Yeah.
Yeah, not too bad. Even though we were fighting the clouds, I think we got some pretty cool views nonetheless. So it looks like we still kind of almost have it in the Vixen. We're getting updates. We can't actually see it ourselves, so we're relying on outside chat features. So that's kind of why we might pause and like think about it a little bit, is because we can't actually see with our own eyes. You guys are the lucky ones that can see it. So
yeah,
almost there though. So
okay,
it looks like we do kind of have it. Nice. So at least one live view, which we can see, which is exciting. So even though we just passed the total part, it still probably looks like a fabulous red color, even though it might be kind of cloudy. So still kind of interesting, even though we kind of missed the total part. It's okay.
Still cool.
Yes, definitely.
So looks like we're doing a 729 millisecond exposure right now on that Vixen. And it turns out the sun is rising. So that's fun. I guess it is almost daytime here, Claire.
It feels like time has slid so quickly. I'm honestly shocked, but I had a lot of fun, so.
Yeah, I hope you guys did too, because I mean, this was awesome for us. We got to come out here and play with the telescopes and like talk about space, which is always super cool, even if it is 4 a.m. 4 a.m. on a Tuesday.
Yes. So we can still spend a little more time. So if you guys have any questions, feel free to put them in the chat still, or anything like that. It doesn't necessarily have to be questions about the lunar eclipse itself. It can be about Lowell Observatory. It could be about us, I guess, if you really wanted. But feel free to kind of just spread out and ask any questions that you like, and try to enjoy as much as we can with the view through the Vixen telescope right now. So it looks like the Vixen is soon-ish gonna lose it to the trees as well. There's, we think, about a degree until it kind of gets into the trees itself. But we'll hold out as long as we can. So yeah. So
well, I guess while we're getting this cool view, we can talk a little bit about the Malin Cam that we're using. So it's a nice little camera software. I love Mali. It's actually really funny. When I first started here, our Malin cam had to be wheeled out on a cart every night, and we had to like hook it up to a TV and plug in the extension cord and everything. Nowadays, we have this really fancy Giovanni open deck observatory with these really nice Planewave telescopes that can hook up to the Malin cam software. So it's much better, beautiful views, and we can manipulate the images. So like we've been seeing, we can manipulate the gain on the telescope, which is kind of like the sensitivity of the telescope. We can change the exposure times. So we can do milliseconds up to like minutes. We've taken like minute-long exposures through this before. They all look pretty fantastic. Right now, apparently the gain is very maxed out on the Vixen. So both of the telescopes right now are using different Malin cams. The one that is showing like the largest on your guys' screen is the Planewaves one. So, okay, I love this question. So we got a question, in our opinion, what was some of the most amazing things we've observed at Lowell Observatory? So it looks like, is that Jose on the Vixen? Joe said the conjunction for sure. So Joe thinks that the conjunction was the best thing that they've ever seen on at Lowell Observatory. What would you say is your favorite thing, Claire?
I really liked when I could see the Mercury transit that happened a couple years ago. That was really cool because we had basically just opened the Godot deck. And so we had a bunch of fancy new telescopes to like see this new transit happening. And so we used it in a couple of those, which was really exciting. We had to get up like super early in the morning, which is kind of like weird for us night owls who stay up all night gazing at the stars, but it was totally worth it. So I would say that's one of my favorite ones. Or looking at Pluto through our old historic Clark telescope, which is, its birthday is coming up pretty soon. So keep an eye out for that. But that was kind of cool too. So what about you, Haley?
So mine's not like visually, but it's more like a nostalgic thing. So our historic Clark telescope, you have to go through like 7 different training sessions, and then you have to like take a written and oh, whoa, there's Jupiter.
Nice.
Anyway, but yeah, we had to go through the different, wow, that's really pretty. The different trainings and the tests we had to take. And during my test, we had to like fight through the clouds for the first 30 minutes or so. And by the time it ended, we got to see Neptune, and Neptune's my favorite planet. And even though it was like a little blue dot, it was a little blue dot that I found through a 125-year-old telescope. So I think that was just like the coolest thing I've ever done. So yeah, but
really cool.
Like you saw there on Malin Cam, there was Jupiter, and now we're gonna move over to Saturn,
Ooh,
which is, oh, look at that little guy.
I missed these too. They went away for a while and they're back now, and I'm very happy about it.
Yeah, one time I looked at Saturn through one of our telescopes with a nebula filter, and nebula filters, they kind of like manipulate the color of an image to kind of bring it out brighter. And I looked at Saturn with it on, and it was bright blue. It was like teal. And I don't know why I found that so funny, but I was like literally crying because I was laughing so hard about this little blue Saturn. But yeah, there's our little guy Saturn. It's also really cool. Galileo, he looked at Saturn and he said that it had ears because its rings kind of looked like ears to him. So
I like that.
Yeah, I think it's really cool. So there's 6 little rings, beigey color.
Yeah, nice. Well, I'm glad we could catch some of the planets on our way out, basically. So they are, of course, rising in the morning. So if you're a morning bird, then that is nice for you guys. So hopefully we'll be able to continue to see some of these planets as time goes on, because they're definitely stellar to look at in the night sky. For sure.
Stellar. No, they're planetary.
True. It just doesn't sound as cool, I guess.
Yeah, sorry guys, they pay us to be smart, not to be funny. So
very true. So let us let us know if you have any last minute questions. I think we basically ran into a tree for the Vixen as far as I heard last. So I'm not sure how much more we can get through that guy. So let's see. And clouds, of course. It looks like we have another comment. Of all the streams that are covering the lunar eclipse, this one has been the best and the one I've stayed the longest and watched for hours. That's so cool. Thanks for joining us. We love to hear your feedback. That's awesome. And thanks so much. I'm glad you enjoyed it. I definitely enjoyed it, and I know Haley did too. So yeah, that's awesome.
Yeah, I always enjoy getting to talk to people about space and stuff. Yeah, this view of Jupiter is actually really cool. We can see one of its bands on there. I like to call those Jupiter's tan lines because the whiter part of Jupiter has high concentrations of zinc, which is the active ingredient in sunscreen. So it looks like Jupiter just like missed some parts of him with the sunscreen when he went out to like go to the beach or something. I don't know.
Yours is much more scientific than mine and well thought through, but I call them the bacon strips of Jupiter, so.
That's even better.
Probably not as scientifically formed as yours, though. I don't know much.
I mean, yeah, those are really cool. Those are little storms going across Jupiter.
Always fun to see.
Yeah.
And so really if we actually like kind of overexpose the planet itself, we can start to get to see some of the moons of Jupiter, or at least the 4 Galilean moons, or yep, there's 4, it looks like, as far as I can see. So they're circling around them. So the 4 Galilean moons were the moons discovered by Galileo with his telescope. So that's how they get their name, basically. There's some pretty cool moons in there. So one of them is Europa, which is kind of hot science right now because we think that there's some cool underground oceans there, and we're planning to send some specific spacecrafts to delve into more dynamics of the moon, which is really cool. So exciting things with Jupiter coming up hopefully pretty soon.
My favorite moon is Io. It's actually my favorite moon in the solar system because it's the smallest of Jupiter's 4 Galilean moons, and it's the closest, and it's just like this little angry dude because Jupiter's pulling on it so hard that it's in like basically its insides are, the lights just changed in here. Basically the insides are like coming out the sides in these giant volcanoes, and it's like the most volcanically active body in the solar system. I almost said the universe. Probably not the universe.
Very true. Yeah, Io is a pretty cool place. Not cool, it's probably really hot with all that volcanism going on, but
yeah.
So it looks like we did just lose the moon in the Vixen. So I guess we'll try and at least give you guys one last pretty look that we took a little bit just before the total eclipse happened of this moon right here. So we can see at least that nice pink or red color. It's quite close to the total eclipse, so it looks pretty much the same, I would say, but not a bad view for a night that was where we were fighting clouds. I would say this is a win over anything, so.
Yeah, no, I totally agree. I mean, even just getting this view right here was pretty fantastic, just seeing this brilliant red color in here. I mean, even though we didn't get to see most of the total eclipse, I think it was still pretty worth it, right?
Yes, definitely. I agree. And then hopefully in the end too, you guys learned a little bit about what a lunar eclipse is and a little bit more about the moon and the history of the Apollo missions, and also something to look forward to with the Artemis missions to come. So I don't know, maybe you'll have trivia questions, then you can relate back to this. That would be kind of cool, but I don't know. Seems oddly specific, so.
Hey, I mean, you never know. Maybe they're going to like an astronomy trivia night somewhere.
That would be kind of cool.
That would be really cool.
So yeah, I think we did definitely lose the moon in the Vixen. So yeah, this is just a nice last look at what we were able to do tonight. And we want to thank you guys all for sticking with us in the early morning to try and view a total lunar eclipse. And I hope that in your location, wherever you were in the world, you had a little more luck than we did But for those of you guys who stayed on, we thank you so much. We always appreciate you guys coming out to support Lowell Observatory with our live streams. Always really fun to do. So, yeah.
Yeah, and thank you guys for coming out here. And again, thanks to the whole team that put this together. I mean, we've got people operating the telescopes, people helping out in the group chat, all kinds of stuff. So it really does take a village, you know. So I really appreciate everyone. And I hope you guys join us again soon for other live streams that we're going to be doing. We've also got a lot of interactive stargazing and different things that are already on our YouTube channel. So if you haven't checked those out, I highly recommend you do. They're totally worth it. So yeah, I think that is pretty much all we've got for you guys tonight. So thanks a lot.